Howdy, and welcome to this short little video on how we can use algebra to calculate the rate of change with respect to time. And to do this, we'll use this simple example problem where we have a space shuttle, and this shuttle achieves orbit at 9:23 a.m., but then some period of time later at 9:31 a.m., it has traveled 2,309.6 miles into orbit, and we're asked to find the rate of change in miles per minute. So what we will find, what we'll see, is that this is basically an exercise in calculating the slope of a line. So on the y-axis, we can write distance, and in this case, the distance is measured in miles. And on the x-axis, we can write time, which is measured in minutes. And so what we know from the problem statement is that at 9:23 a.m., that's our starting point when the space shuttle achieves orbit. And then some period of time later, at say 9:31 a.m., the space shuttle has traveled 2,309.6 miles. So to find the rate of change in miles per minute, what we're really doing is we're calculating the slope of this line. Distance traveled is miles, and knowing that distance traveled in miles per minutes is the slope of this line. So we know that the slope, m, is equal to the change in y divided by the change in x. And so in this particular problem, the change in y is our change in distance, and our x-axis is the change in time, specifically in minutes. So we know that the space shuttle travels 2,003.9 miles. That's the change in distance. And it changes time as we go from 9:31 a.m. and 9:23 a.m. And so our change in time is 8 minutes. So we can go ahead and replace the denominator with 8 minutes. And one of the important things that you'll note in the way that this is written is that I have miles in the numerator and minutes in the denominator. So my minutes are actually helping me, my units are actually helping me know how to set this problem up to find the rate of change. The answer that I arrive at needs to have units of miles per minute. So that means that I need to structure the problem such that I have miles in the numerator and minute in the denominator. And that's exactly how I've written my slope. I have miles in the numerator and minutes in the denominator. So now I can simply do this calculation in my calculator. And when I do that, I get that I have 2309.6 miles divided by 8 minutes is 288.7 miles per minute. And so that's my answer. Now, we all have familiarity with driving in our vehicles, and we know that we generally report speed as miles per hour. So the slope that we've calculated here as miles per minute is a type of a speed. Speed is distance over time, and that's exactly what we have. Distance is miles divided by time, which is minutes. But when we measure the speed in an automobile, for example, we're reporting miles per hour. We can convert this value that we got, this 288.7 miles per minute, which we don't have a lot of familiarity with. We very rarely report the speed of something as miles per minute. We almost always report it as miles per hour. So we can convert this to miles per minute, where we simply do a conversion. And so I write out my 288.7 miles per minute. And then using the way that I've written my units, I want to convert miles per minute such that it's miles per hour. Well, I have time in the denominator, I have minute in the denominator, but I want hours in the denominator. So what I do is I multiply this number, this 288.7, times the number of minutes that are in an hour. And so we all know that there are 60 minutes in an hour. And now look what happens to my units. I have minute in the denominator, and then I have minute in the numerator. And so my minutes cancel, and my end result will be units of miles per hour. And so I can go ahead and plug this into my calculator, where I take that 288.7 and I multiply that by 60, and now I get a huge number, 17,322 miles per hour. So when a space shuttle is traveling through space or is in launch, seeking distance from the Earth and is going into orbit, it's traveling as fast as 17,322 miles per hour. Quite a bit faster than what you can drive on the I-65. But that's the speed in miles per hour.